Howdy, it's tubalcain again. Today I wanted to talk a little bit about sine bars. It's not something you use real often, but a sine bar is, we have one here in a box, a 5-inch sine bar, and it's nothing more than a tool that is used to measure angles in metalworking. Now you can measure incredibly accurate with a sine bar, so much more so than with common protractors that you see around the machine shop. And I even, someplace around here, I've got one of those Brown and Sharp protractors that'll measure down to a minute. But these sine bars will allow you to measure or do layout work within, let's say, 10 degrees, 11 minutes, or whatever you want. They're 60 minutes in a degree, so they're extremely accurate. Now a 5-inch is the most common size, but they do make a 10-inch, and then I have here a little 5-incher. This is just kind of a cheap one from Travers, and it's handy because it's slim enough to where you can fit it in the vise of your milling machine. But we won't talk about that so much today, but we're going to talk about the sine bar, and then in the next video I'm going to tell you several applications for the sine bar, but today we'll just discuss the sine bar itself. Now, if you want to find out more about sine bars, go to wisconsinonline.com and do a search for sine bar, and they have a little animated feature there on sine bars that I think is so well done and better than anything that I can do right here. A sine bar was a project that was often made by a tool maker apprentice in his last year of the apprenticeship because this is an accurate tool, and it was kind of the rite to passage for a tool and die maker or a machinist. This is a commercially made one by Fowler. It is exactly 5 inches from the center of this cylinder to the center of this cylinder, and since that is 5 inches exactly, if you use your machinery handbook, and there's 10 pages or so of sine bar constants, and they all refer to a 5-inch sine bar. So I'm sure that you either have one of these handbooks or you can get one, but you will need this, a sine bar, and a set of gauge blocks. Now, I don't have a full set of gauge blocks. I have one lousy gauge block. I don't know where it came from, but I use it to check my micrometers. This is a Weber gauge block. Those can be bought through Starrett. But a set of gauge blocks costs hundreds of dollars, and they make them in different accuracies. But even the cheapest shop grade is very, very accurate, and the laboratory ones are lapped to within a millionth of an inch, so they're just very expensive. But if you don't have these, you can buy a set of these measuring discs pretty cheap. I think these are only about $30, and a combination of these stacked together will give you just about any possible thickness measurement that you would want or that you would find in that machinery handbook. So you will need these or gauge blocks in conjunction with the sine bar. And here's the reason why. We take a sine bar. Now this is on a granite surface plate, so you need to do this on a very accurate surface, not just a wooden bench. But if you put, this is 1 inch, if we put the 1 inch under there like that, and we look it up here, we will find the exact angle that it is setting at. I'm just doing that as an example, because what I'm going to do now is I'm going to look up an angle in this book, and I'm going to put my gauges together and lay them under there to show you how to set it. So what I'm going to do is set this for 10 degrees and 10 minutes, and that is 0.88255 thousandths. So I'm going to gather the necessary blocks out of here and ring them together and show you how that is done. Now, in order to get 10 degrees and 10 minutes on the sine bar. We need 882 thousandths. So I'm going to forget about the fives on the end, and that figure was found in the machinist's handbook. But since we do not have a genuine set of Joe blocks, we're kind of on a budget here. The closest I can get is 882 thousandths, and I did that by selecting a block in here, one that was 700, one that was 80 thousandths, and one that was 102 thousandths. That gives me a total of 882 thousandths. Those are stacked together, and these don't ring together very well. That's W-R-I-N-G, because they are used and have a few scratches on them. But if you got a brand new set or you got gauge blocks, you can ring them together, and what that means is that after you wipe them, slide them together like this, they should stick together, and I can't get them to do it because they are too old. So instead, these are threaded holes. I've got them screwed together with a set screw that's supplied in this kit. And then if we were to measure them, does that show up? See, we got 882 thousandths, depending on how tightly I move the calipers. So we know that this is accurate. If you don't have a set of these, you could actually machine something or grind a piece of stock to whatever size you wanted very accurately. It would serve the same purpose. And doing this on a surface plate now, wipe everything clean, and when we lay the sine bar on the blocks, we know that this angle now is 10 degrees and 10 minutes. Now, since we dropped the 5.5 over there, that might throw us off a few seconds, but we are pretty darn close to being 10 degrees 10 minutes. That's so much more accurate than using a protractor if you're doing something that really matters. Now, a lot of times it does not matter. Now, that could be repeated by and you can find any angle you want. There's several pages of these, and it tells you how much your blocks need to be. Now, I didn't mention anything about trigonometry, but this is all about trigonometry, and a sine is a function of trigonometry. If you've had that, you will understand some of this, and I'm not going to go into that because I'm not that sharp on trig myself. It's many years since I've had trig, but this is all about triangles, which trigonometry is triangles, the study of triangles. And the top part here is the hypotenuse, and then we've got the right angle down here, and we're just changing the angle by stacking these up. And that's all I'm going to say about the math. I'm not too good at that, but if you look on that website, you're going to find out a lot more about that. But this is what a sine bar is, and then this could be put right in your milling machine vise, and a piece of material laid on there if you were going to mill it, or it could be used on the bench here for measurement or layout or inspection. So don't let the word sine bar scare you. You can get these fairly cheap now. Of course, they're all made in China, but they're still plenty accurate. They are hardened and they are ground and precision made. Usually come in some kind of fitted case. Hope this was helpful if you're interested in sine bars at all. And go to that website. Now watch the next video, and I'm going to show you a couple things that we can do with the sine bar, including setting the head on the Bridgeport. And we'll use that spindle square that I showed you a few videos back and set the head for an angle. These also can be used on the lathe to set the compound or the tailstock offset. This is Tubalcain saying so long for now. I'm going to show you an alternate way of calculating the amount of rise that you need on these blocks if you do not have a machinery handbook. If you do not have this book with all the tables, we can do it mathematically. However, you will need this little book of trig tables that most machinists have, and there still isn't really any math involved. All you will do is we're going to calculate it for 12.5 degrees, so find, which is 12 degrees 30 minutes. We're on page, the page that shows 12 degrees, and then 30 minutes is halfway down here, and we've got columns here: sine, cosine, tangent, and so on. We're not interested in any of them except the very first column, which is the sine. So go on down to 30, and it is 0.216 and change. So that is the number we want, and it's that simple. And then we multiply that times the length of the bar. And we've got two different bars here. We've got a 5-inch bar, and we got this little 3-inch bar. I think I called this something else before, but this is a 3-inch bar. And in order to get the 12.5 degrees, which is 12 degrees 30 minutes, we just found the sine of 12 degrees 30 minutes, which is this. And for a 5-inch bar, multiply it times 5, and you come out with 1.082. That is how many spacers I have stacked here for that. 1.082. For the 3-inch bar, it's 3 times the sine, which is 649, and I have stacked these little spacers to 649. So both of these are going to be set for 12.5 degrees. When I set the sine bar on that, that's 12.5 degrees. That's the 5-inch bar. When I set the smaller 3-inch bar on this, it'll also be 12.5 degrees. I have to be careful not to set it into that set screw hole there, or I would get a false reading. So both of those sine bars are set for 12.5 degrees in that manner without using the big table book, but I guess you do have to use the small table book. You wouldn't even need this if you knew all of your trig functions and are just able to find the sine of an angle mathematically, which you probably learned many years ago in math and have long forgotten, as I have too. And all machinists use these tables here. They don't do a whole lot of math. Hope that was helpful.